All right, so this video is going to cover 11.2 in Algebra 2, and it covers probability. So let's define probability. What is it? It is how likely an event is to happen. So let's think about how we see how likely something is. Usually we see it in a percent, which would go from 0 to 100%, meaning 100% is it's going to happen, right? And then 0 being it's not going to happen. The numbers are between 0 and 1 as well, because if you think about it, if I have zero point 0.9, that's the same as 90%. So you can either see it in terms of a decimal between 0 and 1, or a percent between 0 and 100, and you have to pay attention to what the directions ask you if you need to put in a decimal or a percent for your answer. So there's two types of probability that we're going to discuss, and one is experimental and one is theoretical. So experimental is you actually gather data by doing trials or a simulation and base your probability off this experiment that you did. So this could be actually flipping a coin over and over and over and over and seeing how likely it is to get a tails versus a heads. We know with theoretical probability that the probability of a heads or tails are equally likely. So there's 1/2 or 50% chance of a heads or 50% chance of that tails. But if I do an experiment, I may get, one of them is 49, one's 51, or a little bit off. That theoretical probability. So a lot of things that we see on the news have used experimental probability. So what is the probability of my hair growing back kind of thing, right? Everyone's like, oh, it'll grow back. We'll see. It's an experiment, right? With all the people who've had cancer, how many is hairs grown back? All right, so the probability of an event is kind of labeled in that function notation. It's a capital P, probability of whatever they want. So I just used a generic event. And for a simulation or a trial, it's the number of times that event occurs. So maybe you're looking for heads. How many times did that heads occur out of the total number of trials that you did, or the number of times you flipped that coin? So you divide those, and that gets you your probability in terms of a decimal. You could move it two places to get the percent. So I did want to make sure we understand what a simulation is as well. It is a model of an event, and I'm going to give you a simulation, and we'll go from there. So a simulation could be, well, it could be like where I assign a number on a dice to everyone's grade. A, B, C, D. I think there's 6 on that one. So A, B, C, D, F, and I have an extra one. So maybe the last one's an incomplete or something like that. And I just roll the dice, and that's how I give you your grade. That's a simulation of the event that gives you your probability of getting that grade. That wouldn't be very nice of me. Okay, so let's do some examples of, well, actually, I'm gonna do a couple more definitions, and then I'll just do some examples. Boo boo. All right, so let's look at what is sample space. Sample space is used a lot, and it uses those combinations and those permutations in that counting principle that we looked at in the last chapter. Sample space is how many outcomes are possible. So you may want to see the probability of a certain amount of them, but how many are possible? Theoretical probability, we've talked a little bit, is the idea of that each outcome is equally likely. So theoretically is what we think should happen, basically. And we use a lot of cards and dice for theoretical, and in a lot of the examples you'll see. And here's kind of what I've already said. Flipping an actual coin is an experiment where understanding that heads and tails are equally likely is that theoretical idea. And let's go ahead and look at some examples of all of the above. All right, so my first example could be if there's 60 cars in my parking lot, and 15 are trucks. I should have said vehicles, I guess, than cars. But there's 60 total vehicles because cars kind of implies a little car, right? And there are 15 trucks. What is the probability of a truck being, if I walk out there and grab a car, what is the probability that it's a truck? So I'd write that maybe as P of truck. What is the probability of that truck? Well, how many trucks did I see? Well, I saw 15. How many total cars were in that? The sample space is 60. And that's our probability. So I can divide this and I'd get 0.25, which is the same as 25%. So I think a lot of yours answers have to be put out to the third decimal place in Math Excel. So I think that's how they did a lot of them. This is an experiment or an example of one where I could walk out and actually count cars and tell you a probability based off the cars. Okay, so what is the probability of rolling a 5 on a dice, on a regular dice? So what is the probability? So this is more theoretical. Think about a dice. If I roll it, each side is equally likely. And how many total sides are there, right? That sample space. How many sides are there? There are 6. So what is the probability of a 5? Well, how many times do you see a 5 on a dice? Once. So it's 1/6 the probability of a 5. We could up that, still thinking of a dice. What if I rolled two regular dice? What is the probability of a 7? If I'm adding those 2 dice, roll 2 dice and add. All right, so we've upped it. So if you think about games like I play Catan and the probability of a 7, why do they make that the robber on Catan? Well, let's think about it. So if I'm rolling 2 dice, how many ways can I get that 7? I could do a tree diagram, and that would kind of help with how many 7s. So here's kind of the idea of what I'm thinking. We could roll a 1, we could roll a 2, we could roll a 3, a 4, a 5, or 6. These are independent events because one doesn't affect the other. Then I roll that next dice. Well, if I roll a 1, I could roll another 1, a 2, a 3, a 4, a 5, or a 6. I missed the 5. They're a little backward. Now, what do those actually add to? Well, if I got a 1 and a 1, I would get a 2. If I got a 1 and a 2, I would get a 3. 1 and a 3, I'd get a 4, and then a 5, and then a 1 and a 4 is a 5. 1 and a 6 is a 7. 1 and a 5 is a 6. So here is 1, 7. I was able to get 1, 7 here. If I rolled a 1 and a 6, I could get my 7 I'm looking for. Let's look at the 2s. I could roll a 1, a 2, a 3, a 4, a 5, a 6. And how many of those make a 7 when you add them? Well, 1 and 2 is a 3, 2 and 2 is a 4, 5, 6, and then I have 5 and 2 is a 7, and 6 and 2 is an 8. So again, I have another one here. Here's another 7 I could have rolled. And then I look at 3. Goodness gracious, I can't quite fit them all in there again, but let's write 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And how many on the 3 combinations actually make that 7? 4 and the 3 make the 7, right? So there's still just 1. There's no other way on that one. 4 and a 5, 6, 7. A 3 make the 7 here. 5. I could do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. and 5 and 2 make the 7, and then 6, 1, 2, 4, 5, 6, 1 and 6 make the 7. So how many total 7s are there? So this is kind of, now you'll kind of see why we've thought about that, permutations, combinations, and you can use some of that logic for some of your probabilities. But for this one, there are 1, 2, 3, 4, 5, 6 different ways to make a 7. I'm going to write my probability over here. And how many total ways were there? Well, 6 times 6, right? Because if I added all 6, 6, 6, 6, oh, that's not good numbers. 6, 6, 6, 6 is 6 times 6 is 36. So there's 36 different combinations with those dice. And so 6 divided by 36 is going to get you 1/6. And that is about 16 or 0.167. If I went 3 places out, make sure you round right. And I think that's what they're looking for. That could be 16.7% as well, but I think they're looking for that decimal when you put it in there. So you can use some of those tree diagrams or other ways to think these through. This one's not as easy. So it's only 16% likely to get that 7. Well, what about, and this is the probability of a 7, now that I have it all written out, what is the probability of a 2 versus the 7? Well, the 2 is on the board of Catan is like one of the crappy spots, right? You don't want to pick it. Well, why? The only way to get a 2 is right here, 1 and a 1. So there's 1/36 chance to get that 2, which is about 0.028, because that goes 7, 7, 7. You got to round it. So that's 2.8%, a lot smaller than that 16%. So it's a lot less likely to get a 2. And you could play with the idea of gambling. I try not to use those as examples. But that you could see the dice games, and that kind of helps you with adding the 2 dice. Okay, so what if I drew a tree? This is my 4th example, I think. Well, I did 2 in the last one, but still, it was the same idea. What if I drew a Venn diagram, and they kind of assume you know these by now, and let's say math, science. These are the likelihood that you're in a math class. Let's fill out these numbers real quick. What do all these mean? So you do have some problems that have these, and I'm not so worried about you being able to figure out the probability of them. I'm more worried that you know how to read the graph. So math, science, this is the number of people who are just in a math class. This is the number of people in both. This is the number of people just in science, and this is the number of people in none of them. To get the total sample space, how many people are we talking? We add all those numbers up, which is 147. So you have to be able to know how many total people are in that sample space in order to be able to find probabilities. So that's probably the first thing you want to look for is, well, how many things are in this? So then you could look at, like, what is the probability of maybe not taking math? So what is the probability that you're not taking a math class? Well, this you're in just math, this you're in math and science. So this one's only science and this is none. So you would add the 21 and the 31 over the 147 to get that probability, which then we just divide it out on our calculator, and I get about 0.354 going out 3 places. 35% of those people in this sample space are not taking math. What about the probability of the people taking math? How many people totally are there taking math? Well, this one's both, right? So they're still in a math class. So you have to add these two, 43 plus the 52 over the 147. Well, 43, I did not do the decimal in this one, plus 52 is 95. 95 divided by 147 is about 0.646 or 64.6%. So you get the idea. All right, so just reminding you how to get the numbers basically off of that Venn diagram. All right, now the last thing I want to show you is a simulation. All right, so I'm going to let 1 equal correct answers, and I'm going to let 0 equal incorrect. And I'm going to simulate numbers, and I actually just printed off one of the problems in Math Excel. I printed off their simulation results, but this time this is going to represent a 6-question. So 1, 2, 3, 4, 5, 6 question test, and I simulated 20 different samples. So the sample space is only 20. That means I didn't do this very many times. Really, 20 isn't going to give you a very good example of what it would be like. This is really what it would be like if you guessed on a quiz. So if I guess, and there's 6 questions, what's the probability of failing this? So, well, 3 or less is failing. So I want to know the probability of less than 3, or 3 or less than 3. So 3 does fail, right? So 3 or less than. I want to really know that probability of failing. So let's look through our sample, and I'm just going to highlight the ones that you failed. So, all right, the first one you got more. So this one has just 2 correct. So it's a fail. This one's 2 correct. It's a fail. That one's 3. You failed. You failed. That's 4. That's 3. You failed. That's only got 1 right. That's got 3. 3, 4, 4, 4, 5, 4. So how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 failings out of the 20 total. So what's the probability of failing when you guess? 9 out of 20, which is about 0.45 or 45% chance of failing based off of the simulation. Now you can make your calculator give you random numbers to do a simulation. It's in that probability section here under math. So I'm going to click math. Make sure you can see that. There we go. Click math and go over to probability, and oops, I went too far. Probability, and this first one it's random integer, and you'd click that one, and you then have to tell it from where to where. So from 0 comma to 10 maybe. I want numbers between 0 and 10, and I want how many different times do I want those random numbers? Maybe I'll do that 20 from like before that I just saw, and enter. Okay, here they are. They gave us between 0 and 10, 20 random numbers. There they are. So you can do simulations using, assigning certain probabilities and then doing a simulation on a calculator or some kind of device that randomly gives you the numbers, and you can do a probability based off of that. So hopefully this helps you with this section.